Today we are discussing about dequeue algorithm. Dequeue means delete an element from a queue. Queue is a first in, first out list. Which one is first in? That is out first. First in, first out list. That is, a queue has two ends. That is, front end and rear end. Rear end means back end. Insertion is happening at front end. That is, we are deleting from front in queue. Then what happens to the front? Front is incremented by 1. See here, queue is a linear array of n elements. Means the name of the array is queue and the maximum number of elements is n. Then there are 2 pointers, front and rear. Front is a pointer pointing to the element to be deleted, and rear is a pointer points to the last inserted element. Then in deletion case, which is the condition we need to check, in which case we can't able to delete an element from a queue. If queue contains no element, or if the queue is empty, we can't able to delete an element from a queue. Then in which condition the queue is empty? Front is equal to null means queue is empty. That is why in step 1 we are checking if front is equal to null, print queue underflow. Queue underflow means queue empty. In that case we can't able to delete element. If front is equal to null, print queue is empty or queue underflow. Then from which position we are deleting? Front position we need to delete the element. That is why here we are storing the front position element in the variable ELE. The element in the front pointer we are storing in the variable ELE. Then we can consider one queue. See here in the first queue there are 3 elements in the queue, which is the first inserted element 10, then 20, then 30. In this case, what's the value of front? Front is equal to 0 and rear is equal to 2. Front is equal to 0 and rear is equal to 2. Here, which is the first inserted element 10. So we need to delete 10 because 10 is the first inserted element, because queue is first in, first out. In this case, front is equal to 0, rear is equal to 2. In this case, we are going to delete 10. After deleting 10, what happens to the front pointer? Front is incremented by 1. That is, front is equal to front plus 1. Front is equal to 0 plus 1, that is equal to 1. Now there are 2 elements in the queue, 20 and 30. Then next, which element you are going to delete? 20 we need to delete. After deleting 20, what happens to front? Front is again incremented by 1. That is, front is equal to 1 plus 1, that is equal to 2. Now there are one and only one element in this queue. See, in these 3 cases, rear is not changing. See here also rear is equal to 2, rear is equal to 2, rear is equal to 2. In these 3 cases, rear value is 2 itself. It is not changing. Then which pointer is changing? Front pointer is changing to front plus 1. Here 0 is changing to 1. Then 1 is changing to 2. That is, front is equal to front plus 1. Then we can consider this situation. In this case, how many elements are there? One and only one element in the queue, that is 30. In one and only one element means, what is the condition? Front is equal to rear. Front is equal to 2, rear is equal to 2. That is, front is equal to rear. Front equal to rear means there will be one and only one element in the queue. Then, suppose we need to delete this 30 also. then what will happen? If you are going to delete this 30, after deleting this 30, the queue will be empty. Because here one and only one element, if you are going to delete that element also means, then you will get an empty queue. After deleting this 30, queue will be empty. Queue is empty means front value and rear value will be null. That is why if there is one and only one element in the queue and after deleting that element, we need to get an empty queue. Means we need to change both the pointer. That is front and rear will be equal to null. Then how to write the algorithm? See here, the special case means one and only one element. In which case one and only one element in the queue? Front equal to rear. Front equal to rear means there will be one and only one element in the queue. In that case, if you want to delete, we need to change both the pointer. That is front equal to null, rear is equal to null. In all other case, front is equal to front plus 1. That is, if there is one and only one element in the queue, if you are going to delete that element also means queue will be empty. Empty queue means front equal to null, rear is equal to null. In all other case, front will be equal to front plus 1. This is dequeue algorithm. Dequeue means delete an element from a queue. From which position we are going to delete? From front position we are going to delete. Then in deletion case, which is the condition we need to check. If queue is empty, we can't able to delete the element. In which case queue is empty? Front is equal to null means queue is empty. So first itself we need to check the queue is empty or not. Queue underflow means queue is empty. Then we need to store the front element in the variable ELE. After that, we need to check if there is one and only one element in the queue. If there is one and only one element, after deleting that element, queue will be empty. Empty queue means front equal to null, rear is equal to null. In all other case, front pointer is incremented by 1. Next, applications of queue. 1. Various features of operating system. Second one, multi-programming platforms. Third one, different types of scheduling algorithm. Then printer server routines. Then various application software is based on queue. Then round robin algorithm. These are all the applications of queue.